right, hey guys, today we are going to do one of my favorite things to do with math. We are going to be doing some data analysis. Data being a set of numbers, and we're going to analyze them. Today we're going to look specifically at central tendencies and a little bit more, but the tendency to get to the center in some way. All right, so a lot of this is review, mean, median, mode, range, those kind of things. Okay, let's dive into mean first. What does mean mean? Mean means the average. The average of a data set. Okay, mean means average. Okay, so how do we do this? First, we find the sum of the data, and then we divide by the number of data points. All right, so over here is my example. Here are my data points. I'm going to find the sum of those, so I'm going to add them all together. 12 plus 8 is 20, plus 11 is 31, plus another 11 is 42, plus 15 is 57, plus 13 is 70. So the sum is 70. I add them all together. You can add them together in any order. Okay, then we're going to divide by how many data points there are. 1, 2, 3, 4, 5, 6 data points. So 6 divided by 70, divide, multiply, and subtract. Bring it on down, bring it on back. The remainder 4, so then 4 is 6. The mean is 11 and 2/3. Then we want to make sure my answer makes sense. Does it look like in the center of all these numbers, whatever they would be, it'd be a little over 11? Yeah, that does make sense. All right, so that's the mean. Okay, let's next go to the median. The median is the middle number of a data set. So we have to arrange the data in numeric order or numerical order. Okay, so think about a roadway. Think about the median in a road. The median in a road is the part in the highway right down the middle. A lot of times you'll have grass on a highway to separate it. So that's the median. It's right down the middle. So if I have my numbers over here in my example, you have to number least to greatest. We have to put them in numeric order. So go small to large. I like to cross them out as I go to make sure I have the right amount. And it does make sense on a set of data to put commas in between. Okay, so there's 2, 4, 6 numbers, 2, 4, we started with 6. So we need to find the middle number. So I go from the outside in, getting to the middle. I have 2 middle numbers, 11 and 12. If you have 2 middle numbers, you need to find the average. If 2, find the average. So what's between 11 and 12? Well, I can find the mean. 11 plus 12 divided by 2, 23 divided by 2 gives me 11 and a half. Okay. Or you could just think, what's between 11 and 12? 11 and a half. All right, so anytime you have an even number of data points, you'll have to find the average. If you have an odd number, then you'll only have one. Okay, next let's go to mode. The mode is the number that occurs the most often, and I have an acronym for this. Mode, if we spell the word mode, it's the most often. Not the most, but what occurs the most often. Dude. Exclamation point. You gotta use all the letters. Most often, dude. Exclamation point. So, looking at my numbers here, I'm looking to see which occurs the most often. If there's not many numbers in the data set, you can kind of just look at them all. But if there's a lot, you'll want to, again, order them from least to greatest. This isn't always necessary. You always could do it, but it's not always necessary. 1, 2, 3, 4, 5, 6 numbers. I wrote 6 numbers. Okay, so we find the mode, whichever one comes up the most often. The number 11's on there twice, no other numbers on there twice, so the mode is 11. Sometimes there will be no modes if no number repeats, or there will be multiple modes. So let's say the number 15 was on there twice, then I would have said my answer was 11 and 15 both. Okay. Next range. The range is the difference, so it's subtraction, between the largest and the smallest number in a data set. Okay, so if you think, let's go look at the example. Again, we could order the numbers least to greatest. That might help us see it. You might already have this list if you're doing multiple of these. So we're going to subtract the largest and the smallest number. So the largest is 15, the smallest is 7. So my range is 8. They range from 7 to 15. So the difference is 8. Okay, next, a new term for some of you, outlier. An outlier is a data value that is much smaller or much larger than most of the other values. Okay, so if we put them in numeric order, it lies way outside the rest. Outlier lies way outside. Someone once told me this data might be a liar. Okay, so if we look at this data set here, most our numbers are in the 70s, 80s, 90s, and then you have 155. That is an outlier. That's way bigger than the rest of them. Okay, or it could be a number way smaller. If I had the number 12, that's an outlier. Might be a liar. Doesn't fit in with the rest. The number that doesn't really tend to belong. There are mathematical ways to find this, but for now in 6th grade, we're just dealing with what's obvious, which number is kind of unusual. Okay. So which is the best number to use when we summarize our data? If we have a data set and we're just looking at the numbers and saying, give me the typical score, give me the typical number, the average, not always the average, but what do most people, what's the tendency here? Okay, so first look to see if there are outliers. If there's an outlier, it could really skew your data when it comes to the mean, when it comes to the average. So when there are no outliers, the best measure to summarize data is going to be the mean, the average. Just add them up, divide them by how many there are. If there is an outlier, the best measure to summarize the data will no longer be the mean, it'll now be the median. Okay. So if we're saying, how old are the people in the class? And we've got a 10-year-old and some 11-year-olds, and then we have a 55-year-old. If we added them up and divided by how many there were, my answer is going to be somewhere in the close to 20s. Well, how old are the people in this class? No, they're not in their 20s. Most of them are 10 or 11. So for that, we use our median because of that 55-year-old in class. Not Happy Gilmore. What's his name? Billy Madison. All right, so let's choose the best measure to describe our data. Lisa wants to determine which letter appears the most often in her favorite poem. Which measure should she use? The mean, median, or mode? Well, most often. Most often means mode. That's our keyword to that. Okay. It could have said which letter appears the most frequently. That would mean the same thing as mode. Okay, we're not talking about the mean or median there. Okay, the next one. In Professor Kim's class, the 10 students had the following scores on their last midterm. Okay, we see all these scores. What should we use for the data? Well, looking at what we said earlier, are there any outliers? No, the biggest and the smallest, they're all within the same range, so we can just use the mean. We can add them all up, divide by how many there are to summarize our data. Okay, next. The last 9 calls to a customer service support line had the following length in minutes. These people are talking to support for a long time. Ooh, look at that, someone talked for 67 minutes. That's an outlier. because we have an outlier, we can no longer use the mean because it's going to skew our data way bigger than it needs to be. So now we're going to use the median. So that would give us, one of these numbers in here. That makes more sense. All right, let's talk about the mean graphically. You can always add up your data and divide by 2, but I want to show it a little different way here. Okay, let's say this is how tall one person in class is. This is how tall another person in class is. To find the mean of that, we're going to just try to find where there's the same amount above as the same amount below. If I put my line right here, there's 1, 2, 3, 4 spaces above, and there's 1, 2, 3, 4 spaces below. So I could cut off this top section, set it here, and they're both going to be the same height. So I didn't have to use any numbers there besides just counting. That's where my mean's going to be. Let's show it with multiple graphs. I can do the same thing. I know it's going to be smaller than the lowest, the minimum, and smaller than the maximum. So let's say I put my line right here. Let's see if that's right. So that one's already that height. We could cut these 2 off. And if we look this way, there's 1 there and 1 there. So I could cut off this top piece, put it here, cut off this next piece, and set it here. And now they're all the same height. So our mean height is going to be this tall because I cut 2 off there and put 1, 2 there. All right, good luck.